Friday, you know what that means. We are live, and we have Alan W2AEW with us. That's a heck of a last name. And Jordan and myself, and we are in Alan's lab, which you guys have missed it. We just spent half an hour going over everything in the lab, and we've not hardly scratched the surface. So cool. You guys have missed it. We just spent half an hour going. Nobody's echoing, though. Unfortunately,
sorry. Turn it off. I turned off the sound. I always have the YouTube stream going to make sure it's actually going, and so I can comment as me. But sorry, I didn't mute it quickly enough.
Oh, right. I don't have the YouTube stream on, so I'm not going to be able to do any commenting. So,
so what do you have in your hand there? Let's jump right into it, Alan. You were showing us this when the top of the hour came.
Yeah, we actually were talking about doing some renovation of old equipment and stuff like that. So this is actually a you can even see this thing, Antique Wireless Association capacitor DC leakage tester.
Wow.
And I put Antique Wireless on there because it's actually a circuit board that they offer. They offer that basically a listed bill of materials. You go off and buy the parts and things like that. So I put it in this nice slanted case. This will put about up to 600 volts across a capacitor.
Yep.
And measure leakage current. And I built it, tried to keep it a little bit safe because 600 volts could be dangerous.
I actually need to make one of those too, because that's important for repairing guitar amps.
Yeah. Oh yeah.
The tone stacks. The number one thing that causes scratchy pots on a guitar amp is DC leakage in the tone stack.
Right. Yeah. So this I put the high voltage stuff up here where the device connects, and you can actually monitor the voltage across the DUT through these ports. So these are the ones that have got the high voltage on them.
Right.
And then the voltage you just dial up here. You can read I found this old Weston voltmeter that happened to have exactly the right scale on it, so I incorporated that in there to measure the voltage. And then you measure current you're basically just measuring the voltage across a shunt resistor. So you apply another meter there to measure, and it's 1 volt per milliamp of leakage current is what the ratio is. So it's real simple. You flip it into test, you rotate it up and look at the leakage, flip it back and discharge, and you can pull your part out. But AC operated, it's just this old box. I did a whole video on this too. But
that's a very cool device.
What's that?
How long ago did you make that?
Oh, maybe within the last 2 years.
Oh, so okay. I'm thinking this is something you made in high school or something.
No. Well, it may look
what
like
did you
it.
Do? I'm curious. What did you do for the labels on the box? Did you have pressure sensitive, or how do you do that? They look fantastic.
What you can't see is it's actually clear tape. It's one of those little brother labelers, but with a clear tape, and so it,
there you go.
Basically that with a clear tape. So, So it looks like it's screen printed on video, but when you'll see it in person, it's clear tape.
Right. We used to use in the old days rub-on letters and then hairspray, and
you want to see that?
Off. Yeah.
Yeah. Let me see if this thing's plugged in. If it's not plugged in, I can pull it down. Because you want to talk about that. Here you go. Oh,
I did that. Remember doing that on. I built a really nice keyboard amplifier for my mom years ago.
Unfortunately, this is plugged in, so I can't get to it. This function generator, I built this in high school, so that's 40 plus years ago, and this has the rub-on letters. And basically, this was a little Elenco function generator kit on a circuit board, and I built it into this box. And then I designed my own amplifier for it, so I could AC or DC couple it, add some DC offset to it.
Lovely.
And, so I got the output in the sync, and then, but yeah, it's actually plugged in. That's why it's like
wow. Now that doesn't use the 80. That doesn't use the 8038 by any chance, does it?
No, it was the XR one, the 2204.
Oh, 2260, 2204.
Yeah, whatever that one was. That's the one that's in there. Yeah.
Some of those, I think some production still got picked up for those because you get the low cost analog function generator kits from AliExpress. They have that.
They
have that part or a clone of it.
2206, I thought it was, but
I thought it was a 2206 as well. I'm pretty sure I have an analog SIG-Gen with that in it. Actually, a couple of them.
Yeah,
I've got to show you mine. It's so bad. Talking about beautiful front panels and labels, I'll show you what I made when I was in school.
Yeah, that's probably one of the only things that survived from that time period, other than the very first Heath kit I built. That survived.
Yeah. So tell us about that.
So this is actually little Heathkit transistor checker. My very first Heathkit. I built this. I was probably 13 or 14 years old.
Right.
And even had the handcrafted by and my name on it engraved on the back of it there, a little label. I'm gonna get the light to show that or not. But yeah, so that was the very first Heathkit I built, was that guy. So
this one, my early one, it's amazing how similar they look. And you were showing us your grid dip meter here in the beginning.
Yeah,
that was the thing about Heathkit. Always had the coolest, you know, actual mechanical enclosures and all that stuff. Like they had everything dialed in like it was a professional device. In Australia, all the kits came from magazines like EA, Silicon Chip. This was my first transistor tester, and it's just an astable multi-vibrator, and it tells you, is it an NPN, a PNP, is it functioning, or is it open or shorted?
Right.
And this was a fancy kit to have a screen printed label on the box. Like that was as good as they came. This is my function generator.
Nice. I like it. Great.
This one uses that chip you were talking about.
Oh, the Intersil 8038.
Yeah, I think it was the XR 2206. I'm pretty sure is inside this one.
Yeah. Cool.
Yeah. They kind of left you on your own with in terms of packaging things up, you know. So as a kid with not all the right tools and no.
Yeah.
I saved my money for a Greenlee punch, because back then everything went in those clamshell bud cases, right? That just. And I could never make a DB25 hole, and I mean I filed away at one when I there it is.
Nibbler.
So I tried to get a better one of those.
I got that one, and that one. I got two of the different nibblers, but I got a lot of. I used that when I made this to cut that hole back there and to cut the hole for the meter. I did that with the nibbler because I don't have the Greenlee punch.
Those punches are expensive.
My wire wrap tool from back then. So very cool.
Well, then a more fancy analog transistor checker Heathkit. So
that one will actually give you things like forward beta, right?
Yes, it will. Yep.
So that's cool. That's the cool difference. Like it's the next thing. The only next thing would be a curve tracer, which we've been chatting about on the show a bit.
Yeah, it's right over there.
Well, Alan, you made a curve tracer with just your Series 2 scope and a transformer and a resistor, right?
Yeah. So actually, let's see if I gotta exit out of full screen here. I think somehow. Let's see. Here we got to do that.
And then we want to see your curve tracer, because that is how this conversation started.
Yeah, let's actually go and share my scope screen here. Let's go to Window and grab that. So that's the 2 series scope. And what I could do is, let's see. Yeah, literally sitting here, even better yet. You still have me on camera? I can't tell.
Yes, we're looking at you.
So that's the schematic. Okay. So it's just a one-to-one audio transformer feeding into your DUT and a current sense resistor. And the only reason I use this is because most of the function generators are ground referenced. And if we want to sense current reference to ground, you want to float it. Okay. If you don't want to do that to eliminate the transformer, then you'll just include the series resistor in whatever you're measuring, because the scope is, unless you got a floating scope. But this way I can ground it here. I can measure voltage across the DUT, voltage across the resistor. The only thing is that they're going to be inverted from each other. So if you're going to do what I did here, is the function generator is feeding kind of right here. That's the voltage across the DUT. If you can see the scope screen. And then the bottom is the current going through the diode. All right. And I just do an XY plot of those two. And I've got the current, you can see the arrow down here is inverting so that I get so it looks like a proper curve tracer. Okay.
We can't see what you're referring to with the arrow. You're sharing. We didn't add you. There you are.
Oh, okay.
Oh, now, there we go.
Sorry.
Yeah. Okay. So so this is on the scope screen. I just have the yellow trace here. Channel 1 is the voltage across the DUT, and the reason it's kind of flattening out is I'm measuring a diode, and the AFG is got a 50 ohm output impedance. So as soon as the diode turns on, it kind of clips it. Okay, and then the current ramps up. So the current is down here. This is the voltage across that current sense resistor, and I inverted that because we're measuring the other way. The voltage is impressed across the resistor the other way, so I inverted it so I get a proper XY plot. So,
well,
and again,
cool.
Yeah, so it's just, very, very simple curve tracer, which actually got me thinking too. I actually did a video a couple years ago. I think it was video number 232, if I remember correctly, that actually shows a very simple transistor curve tracer with just common parts. In fact,
but not the octopus, but something else, or
yeah, because this is really the octopus. This is really the octopus. The octopus is generally made by using like a filament transformer to get down to like 6.3 volts or something, and then just doing exactly what we did. That's the octopus, right? Okay. So this is just a function generator driven octopus is really all this is that I did. But the other function generator I did, let me change what I'm sharing here if I could. Let me let's go and change to share. Let's go to.
Is that a frequency wall spectrum wall chart?
Oh, yep, over there. Yep, yep. So here's the schematic of the simple curve tracer that I made. There's a video on this. It's video number 232, but it uses just a 555 as a pulse generator. Uses another simple pulse generator here as a reset. And then this goes into this interesting circuit here is kind of like a charge pump based step generator. So the output that appears here is the step voltage.
That is, I have never seen an op amp used in. That's like the only thing I think I've never seen done with an op amp. That is,
I'd never seen it either, and it actually was in this magazine from 1999. So I first built this circuit and just described it in a video on it. I said, that's the basics for a curve tracer. So I basically, so you kind of see a little bit of a faint line right here. That's actually a little fold over piece of schematic that I have on top of the original thing to kind of show the pieces that I added to make it a curve tracer. So I took the step generator, just fed it through a resistor into the base of the transistor you're testing, and then created a ramp generator here that could be reset by this guy. So at each step, I ramp the voltage from ground up towards VCC. I buffer that and feed that into a current mirror. So one side feeds the DUT, the other side I can read the current. So if I read the voltage from collector to emitter here and the current mirrored on this resistor, I basically can draw a set of curve tracer traces.
That's fantastic.
So that's video number 232.
You've got here. Oh, that's what I was going to tell you about your videos. The one thing about them is there's so many, it's hard to find. I mean, not hard to find.
Yeah, I don't know how you have time to do them all.
Well, here's the trick. I don't know. Am I sharing my homepage now for the video?
No, we're still on the curve tracer PDF.
Oh, got it. All right, let me see how I can change that. If I had it, I think I got to go to the StreamYard page and change what I'm sharing. Is what I got to do. So let's go and change the share. Yeah, it's not like Zoom where I can just switch. Let's see.
But it's easier than Skype.
Yeah. So if you go to, this is my YouTube channel.
Whoop.
If you go, can you see that now?
Yep.
Okay. Over here, over in this side is a link to a PDF index file. If you click on that, and that brings you to a PDF file of all of my videos, first in numeric order, and then arranged a bit by topic.
Okay.
And you could also, since it's a PDF, you could search it, and then every one of these is a clickable link to the video.
And they can find your homepage by looking for W2AEW pretty much. And
right.
Yeah. Great handle. Mm-hmm. So very cool. So how did you generate your icon, your avatar a lot of time is a phosphor representation of you. How did you create that?
the photo on the scope screen.
Yes.
Yeah, so it's actually, let me see, do I have it down here? Yeah, here it is. So here's how I did it. Okay, enough said.
Hold on, let's.
All right.
Okay.
So this is a NTSC video to X, Y, and Z voltage generator.
Yep.
So it uses the LM 1881 sync separator chip.
Oh, that's one of my favorite chips. Yes.
Yep.
Yeah.
So it's the LM 1881 sync separator. I take the vertical and horizontal sync pulses, and I drive some ramp generators with those. I reset ramp generators with those. So that creates the X and Y scan voltages.
Right.
And then the NTSC, if you just take the magnitude of it, will give you intensity.
Yeah.
Right.
So I use
Z.
that X, Y, and Z into the X, Y, and Z inputs of a scope. So I took the video output from one of my video cameras into this, created the X, Y, and Z into the scope, which turned the scope into an analog or monochrome video monitor. Then I took a picture of that.
Right.
So that's where it came from.
Here, you'll recognize the shirt along those same principles.
Oh,
right?
yes, absolutely. Yep.
Yeah, they have the logo version of what you just described.
The Wizard.
Yep. Yeah.
But what? Hey, question though. The Wizard, wasn't that generated by an actual deep memory, sort of like a waveform generator?
I thought it was a vector list.
Well, the original Wizard was actually a hand-drawn thing in one of the schematics of one of the service manuals for one of the scopes. There's actually a whole website dedicated to Tektronix schematic waveform art. So the Wizard is in there. There's a bunch of others that are in there. You can search for that, like Tektronix the schematic art, and you'll find that. But the Wizard, when you see it drawn, like on a scope screen, the person I know the guy who actually did it originally. He did it on one of the vector terminals, monitors, back when Tektronix made video monitors.
Yeah,
like
for TV stations and whatnot. Yeah.
Yeah, but even just like video terminals for PCs and things like that. It's under one vector drawn. So it was actually they converted it into a vector drawn thing, and then the guy who actually worked on it also gave me the code for it to throw into an Arduino to feed into an R2R ladder DAC to drive it XY on a scope. So
very cool.
So,
it's people these days studying electronics have no clue. Like we used to, even when I was in college in the 90s, we learned all about raster based display systems and everything, every detail about how they work. And even then, they gave it a hat tip to vector, but they didn't really explain it. Except one of the first year classes we did that was all about oscilloscopes and oscilloscope practice. Basically, it was actually one of the labs, and we had to learn all about using scopes and getting the most accurate measurement. And that's where people actually learned what a CRT was. And and it's funny that I've found videos of old mini computers and graphics terminals for mainframes from the 70s, where the early systems that were used for schematic and PCB layout, and they were vector. They had a little round screen, and it was all vector graphics with a light pen. I forget the name of the particular one I'm thinking of, but it was like someone found ancient training videos and posted them on YouTube for fun.
Oh wow!
And if I can find the link, I'll share it in the Discord.
I had a chance to talk with the Atari programmer that did Battlezone, the little vector-driven tank game. And so I just remember the conversation was they had a vector stack processor, and sometimes it'd crash and draw all over the screen and everything.
I've got a feeling Space War was on the first deck, PDP. Yeah, the first ever official computer game. That was a vector-based display as well.
Right.
I love when you get to the source of truth. They talk to the actual guy that did it, you know. And I got a good short story, segue story on that. There was a question that was asked several years ago. I think it was on the EEV blog forum about why do every scope that you find have a 20 megahertz low pass filter option on the vertical channels, and why is it always 20 megahertz? And every scope has it. Why is it there? I mean, I understand why it's there, but why is it always 20 megahertz? Where did it come from? So they're all postulating back and forth, all the people. I was like, I know who to ask. So I went to the guys at Vintage Tech where you got that shirt from.
Okay.
And wound up talking to a guy named John Addis, who was the first guy who did it.
Oh, wow.
So John told me the story. Back then, Tektronix was based in Portland, not in Beaverton.
Right.
And
Okay.
he was working on a wideband, like a 50 megahertz or 100 megahertz vertical preamp for a scope. And they were very close to the local Channel 3 television broadcast station. And it was at 50 something megahertz that was getting into his circuit. So he threw in a 20 megahertz low pass filter to finish his design and left it in there.
Right.
And ever since then, everybody put 20 megahertz bandpass filters in there, or low pass filters in front of those scopes because Tektronix did it.
Right. We had an AM station in our town too, and it got into everything. It got into your bed springs. You could hear the radio station at night from the metal touching metal and stuff. So that's awesome.
So you love when you get to that source of truth. Like, oh, there's the guy to ask. He knows because he did it.
So somebody just asked this question. Sometimes we get those retro questions. So Terry Ryan did that and segue to VCF. VCF is April 14th, 15th, and 16th this year. I'll be there, and Terry Ryan is going to be there on Saturday, the 15th. I think that is the person who wrote "Link Arms Don't Make Them." So come see VCF.
I might have to try to make it down there. So
yeah, if you can make it there, that'd be real cool. So that's where I met you at, actually.
The first time we met in person was there. Yeah, absolutely.
Yeah. And I remember your story from that day. You had been, the way you've got introduced to Jerry Ellsworth was you were texting each other in the airport, and you turned out to be like in the same airport or something.
No, it was actually the other way around. I actually was sitting in the airport waiting area to get on a plane. It was in Portland, and I look over and I said, "That looks like Jerry Ellsworth," because I'd seen like videos or whatever. So I walked up to her. I said, "Excuse me, are you Jerry Ellsworth?" She says, "Yeah." So we started up a conversation then, and then we started texting back and forth. So actually, I had recognized her in the airport.
I got you. Okay, yeah. I wondered how that coincidence worked. Yeah, Terry Ryan did the basic. Yes, Mike Fikes. Terry Ryan did the basic. He did basic that was used by a few million people and doesn't remember doing it. So I like to tease him about it.
I used it on my VIC-20 and my 64.
So did you ever? The VIC-20 was popular with hams because it was quiet, EMC wise. Did you ever do anything with the VIC-20 in the old days?
I never did. I had one given to me and I used it a little bit, and then I wound up buying a new C64 that I brought with me to college. So my first 2 years of college, I used a C64.
Okay.
But it was just more for college work more than anything else. And I used it often as a terminal to get into the mainframe to submit simulations and stuff like that. And I had the old dot matrix printer that didn't have the descending characters and had the aluminum backplate that was like super loud.
Yeah.
You mentioned you'd use it as a terminal to log in the mainframe to simulate. So give us a day in the life of a student back then. Were you using Berkeley Spice remotely?
We used I'm trying to think some of the programs. We used there was a program called TCAP that we used. There was a Spice program. I don't remember which flavor it was. I don't think it was Berkeley, but there were a couple of different simulators programs that we used. And I had a 9-inch black and white TV as a monitor.
Right.
The Commodore 64. I had the printer, and I had the 300 baud modem, that cartridge that plugged in the back. And then also it snuck down into the telephone room in the dorm that I was living in, and I wired in a 3-wire extension to where the mainframe was. So I don't have to dial in through a regular phone line. So I actually had a 3-wire extension to get in there. But I remember cool. I had that whole thing set up, and I was getting ready. I over time I wound up buying an Apple IIe to replace that with. So I advertised to sell the C64. And so somebody came up to look at it. I just submitted something, a job or whatever. So I was showing him the ins and outs to do something. And I said, let me go check just to see how my simulation's doing. And he says, I'll walk down with you. I said, no, I'll do it right here. So I pulled it up, see what. He's like, oh, that's really great. And I showed him a couple more things. And then I said, well, let me go see if the output's done. I checked, the output's done. He was, I'll walk down with you to pick it up. I said, no, I'll print it out right here. I started printing it out, and he was like, how much do you want for this thing?
Dude, no wonder you became a career-long FAE. That's how it works. You just all it takes is someone who knows what they're doing, and this is career advice. And I'm trying to be an entrepreneur now, and I'm learning to cross that river, which is very difficult for other reasons. But if you want a really good career, in engineering that pays better than a just typical engineering job. You might consider being an FAE or sales engineer. But what it takes is someone who really knows the thing and what it can do, and just to be able to show it to people.
Yeah.
So anyway,
Yep.
yeah, I mean, so back then too, Spice and my 90s college textbooks, one of my favorite books from when I was in school in the 90s was by Bogart.
Okay.
Electronic Devices and Circuits, and it's still going. I think he's up to edition 8 or 9 by now.
Okay. Okay.
But the Spice outputs from that textbook, even in 1993, were text.
Yeah.
He would show you'd print see an RC curve or something, or a VI curve, and it was little asterisks across a big table of blank stuff. It's like that's how it was.
Chip guys characterized their silicon runs at MOS back in the days. They called them shrews because they look like a shrew from.
Like you want high resolution output?
Yeah. Well, my
do you really need it?
Yeah,
it was like playing Star Trek in BASIC.
Yeah, because my college days were 81 to 85, so that's what I went to college. So and like I said, I didn't really use a PC based version of Spice until I got my first job, and we used PSpice back then. And
right.
PSpice had a separate program called Probe to look and graphically plot, the output from your Spice.
Yeah, so that was a separate company then. That was Microsim. That's right. Because I had a friend at Altium for years who previously was at Microsim and left when they got acquired by Cadence, and he was a Spice guru.
Yeah, we came to OrCAD because back then PSpice didn't have a schematic front end.
That's right. It went to OrCAD, and then OrCAD was acquired. That's right.
Right. Yeah, because PSpice didn't have a schematic front end initially. So you would write out your net list by hand. So you draw your schematics in whatever tool you're drawing schematics, either by hand or in something. And then oftentimes you didn't have any kind of a net list extractor. You actually had to write out the net list by hand.
Oh my gosh, yeah.
With all the node numbers on there.
The 128, we did a hand net list to get it into the SciCards system.
Yep.
Yeah. So, and that's part of the checks is one guy reading the net list and the other guy inking the schematic, and yeah.
But even like I said, going back to college, like all the programming classes and stuff I took, like Fortran and things like that, that was all punch cards.
Yeah.
So and I remember running through running to get to class with a handful of punch cards, and then having the elastic band let loose and the cards go confetti raining down.
They can be sorted, I'm told. It just takes a while.
Yeah, it does.
Yeah. So what else you got to show us here? You were saying you can see like 31 analog meters from where you're sitting, or what?
Not quite that many, but I'll give you a little tour from here. Well, just out of frame here is the curve tracer that we'll circle back to. But just kind of walking around the room.
Sorry, Bill and I are clicking the full screen button at almost the same time and undoing each other accidentally. So carry on.
I've got what you don't see it out of camera is all tons of little bins that have things like accessories and projects and leads and all kinds of things like that. But equipment wise, this is an old tech 485 oscilloscope. This was the first 350 megahertz scope that would fit underneath an airline seat. But it's got the sharpest it's got the sharpest CRT of any scope that I own. So really cool.
Beautiful. That's the selling. Yeah,
that's a great scope. Whoops. Really great scope. In fact, that's the one that I took the picture on with that my picture. That was I was using that one as the CRT.
Got it.
Just above that is a Booten RF millivoltmeter. I bought it at Hamfest and refurbished, so that's actually really neat little RF millivoltmeter. And this guy is an HP 3400B RMS voltmeter. It goes up to 20 megahertz, and you can range. The scale ranges from 300 volts down to 1 millivolt, so about 110 dB range in terms of the scales you can use on that. Pretty cool.
Yes.
In fact, I have
one that's almost the same as that, but I still need to refurbish it. I got it from a university clearance house.
Okay.
And 300 volts at RF frequencies.
That's a really great meter. In fact, I got to thank Shariar from the Signal Path. He actually gave that one to me. Because he had picked up a couple of them. He actually did a project with one, and I was over visiting him, and he said, "Hey, why don't you take this?" So, in fact, that's the reason I had to revamp my lighting here, because I was trying to do some really low-level measurements with it, and the old LED under cabinet lighting I had here created too much hash. I couldn't measure the low-level signals, so I switched to a DC-driven LED strip underneath my bench here because of that meter.
Yes.
I've heard that the LEDs that people are using, and like Dave Jones mentioned, that are noisy. And I'm because I've been doing this a while, all my stuff is cold fluorescent, so I accidentally dodged the bullet.
Yeah. So I wound up switching over to that, and basically I've got one of my little brick power supplies up here as the DC power source for the LED strip light, so I can actually
just set the current limit.
Yep,
and you adjust the current limit to set your brightness.
Exactly.
It's a good way to go, actually.
Yep. So 2465, 300 megahertz analog scope, kind of the ubiquitous, one of the best bench scopes ever made.
Didn't you say there are two kinds of tubes in that? They one was fuzzier than the other when you saw my 2465.
Well, the 2465 was also made into a version that used what's called the microchannel plate CRT.
Okay,
and that's this scope here, and they called that the 2467. And the difference is the 2467 has got an electron multiplier right at the scope face.
Okay.
So you can see single shot events at a nanosecond per division.
Wow.
Which you cannot see on an analog CRT. So that was before we had digital scopes to capture infrequent little events and things like that. That's how you did it, was with that. Just to give you perspective, that was like a $2,000 scope back in the day, brand new.
Right.
This was $12,000 back in the day, brand new. Okay.
Yeah.
So
a scope cost my salary back in the day. How I remember.
They do now.
Yeah, right. So
look at that MXR.
Yeah.
So, the MXA I'd borrowed from Keysight a few weeks ago. That's a year's salary for that scope.
Oh yeah, absolutely.
Yeah.
Yep. So back in the corner back there is my Metcal soldering iron. I love this thing because it's got such a short little reach. We're working on surface mount stuff. And all these are replaceable cartridges.
I flinched when you grabbed the metal.
So did I.
I made sure it was off. I looked back, made sure it was off.
I was going to say, I have a scar on. Oh, here I have a scar on my arm from a soldering iron burn.
Yep.
So.
Yep. So that's all back there, all the solder back there. It's kind of behind the scopes. I brought this down. It's kind of sitting in front of another power supply that this is a Keithley 2015 DMM that can measure total harmonic distortion and SINAD, and then a Fluke 6.5 digit 8846.
So we talked about the Keithley before we went live. So tell us a bit about that, because that thing's really impressive in my opinion.
Yeah, it's pretty cool because it's based on the Keithley 2000, which is a 6.5 digit DMM, really nice DMM, but it's it's a bit longer in the tooth now compared to some of the newer ones that are out there. It doesn't have a graphical display or anything like that. But the 2015 version of that can measure total harmonic distortion, basically in audio signals, as well as SNR and SINAD, which is signal to noise and distortion. But it was used a lot in like the cell phone industry with some of the early phones to measure audio quality and things like that. But I picked it up on eBay a couple of years ago. But it's a pretty neat box, and I think I've got a video on that too. If you search for SINAD on my channel, you'll find a video where I talk about that and another piece of equipment here that can measure SINAD. So
right.
But that's a pretty cool box. It's just sitting hidden behind here. The main scope that I use most of the time is this guy back here. This is the Tech MDO 4000. So it's a 4-channel 1 gigahertz with a 6 gig spec GaN, all time correlated. Really cool stuff.
Now, the main difference between that and my MDO 3000 is yours does time correlation, right?
Right. Yeah, it can capture RF over time along with your analog and digital signals and look at the choreography of all of that. Where you have the MDO 3000 where it's either analog and digital scope or spec GaN.
Right.
Okay. Right. Here they're the same, and I can capture RF over time with it.
That's useful for intermittent radio sources, or
anytime
all kinds of things, probably.
Because most RF sources these days are transient in nature anyway, right? Bluetooth is frequency hopping, everything's kind of bursted and pulsed or things like that.
Yeah, spread
or
spectrum.
Even if you're spread spectrum stuff, or if you're just like if you're tuning a synthesizer from one frequency to another, you want to see how long it takes to get there, that type of a thing.
Oh yeah.
That's the kind of anything that where the RF characteristics are changing over time and you want to characterize that. That's really what we're talking about. So
cool.
So that's what that guy is. Let's see what am I blocking? So
yeah, I saw Ben Eater had one of the 4Ks.
Okay. So this is just a 2-channel, 240 megahertz arbitrary function generator. A couple of Simpson 260 VOMs, because even in the presence of all the digital DMMs, there's still really good reasons to have analog VOMs in your shack for, especially when you're tuning things. You want to see how things are moving.
Yep.
Couple of just HP power supplies, these little bricks, little linear power supplies. Again, I talked about the 2467 is the 2465 with the microchannel plate CRT. Little Nixie tube frequency counter. That's really accurate. Only goes to 60 megahertz, but the Nixie tubes you can't get rid of that, right? So that's what that is. I've got a couple of RF SIG gens. There's a Roden Schwartz SML01 here. Goes up to 1.1 gig. This Tech 4106 goes up to 6 gig.
Wow.
And then I've got a 3 gigahertz frequency counter here.
So give us
your frequency counter. Saxon?
I'm sorry?
What's the brand? I'm sorry, Ben. What was the brand of your frequency counter you were showing?
Oh, yeah. Well, this counter is a Tech FCA 3003 Tektronix.
Okay.
In fact, I'll turn it off. Might be easier to kind of maybe see it. I don't know, but.
So I wanted to ask about the RF SIG gens. What kind of resolutions in frequency and SNR?
Oh, okay.
Yeah.
So the Tech 4000 series is actually the frequency accuracy of it is really very good. It can run from near DC out to 6 gig.
That's amazing.
It has some moderate, relatively narrow bandwidth vector signal modulation capability. Whereas the Roden Schwartz unit is just analog AM and FM and modulation. But they're both quite good. The phase noise on them is pretty good. So they both got a really wide output dynamic range. They can be dialed down to well below minus 100 dBm up to I think this guy can go to like 15 or 16 dBm. I think it can go to about 18 dBm on the Tech. So
that's fantastic.
Yeah. So, but they're that's why they're center of the bench because they get used a lot.
Right.
Above that, this is actually needs a little bit of work right now. This is actually an old Marconi Instruments FM deviation meter.
Oh, wow. Okay.
What's kind of neat about that, it would automatically sense the carrier and then measure, but it needs a little bit of work right now. So it's just sitting up there as a project. Above this is a unit called a sine adder, and it was basically a meter that was purpose built to measure sine ad. And relatively low cost in the day. It was actually just in a lot of service houses, people working on like CB radios and things like that would have those. This is that homebrew function generator that I had my hand rub labels. Oh, this is a homebrew. This guy here. Let's see. This is I probably made this 20 years ago now. Homebrew ESR meter.
Okay.
So. But so you can see how scientifically I made that scale for ESR. Just a little label.
Right.
I love it.
Rather than even taking it apart, I just kind of put that on.
What would you suggest for people wanting to find nice analog dial meters? I mean, there's a lot. There's a lot of manufacturers still making them. There's a lot of cheap ones on Ellis. But if you want a really good, trustworthy, like high quality analog meter, round faced or square, doesn't matter, but with the mirror behind the needle, where would, other than trying to find something used on eBay?
That's what I was going to say, because you want to buy something like that new, you're $50 to $100 sometimes for just the meter, meter movement. So going to ham radio flea markets, that kind of stuff.
Is it too difficult? Would you say it's too difficult to adapt? Because they're still used a lot in power generation, in the power delivery industry, right?
Yep.
It could be easy at auction or other places to find meters like that, but they'd be for things like COS-FI. They'll have different faces on them.
Right. Well, most of them, at their heart, they're all basically just ammeters. right?
Yeah.
And they either have shunts to change the current, or they got series resistors to change to turn them into voltmeters. And a lot of them, especially the older ones, you can take them apart and make your own labels. There's actually some software out there to make your own labels, your own scale, put it back together again.
And then it's just a matter of setting the dial, setting the set point accurately, and then calibrating. So how would you go about that? Like you did that with your ESR meter, but
yeah. So I mean, generally it's going to be, because most of the meters are going to have some full scale current rating. Okay,
yep.
and that full scale current rating is going to translate to some voltage across the terminals based on whatever the coil resistance is for a
so you're gonna so you're gonna design a meter amplifier to cater exactly to that.
Yeah,
basically.
so if you just make it a voltmeter, you're gonna have some series resistor, and so you have some series resistor and some trimmer to set it up. If you make a higher current version of it, you're gonna design some low level shunt resistor to go around the meter. Okay, that generates the voltage that you want at the current you want to drive the full scale of the meter. And generally, you got to trim those things too. So because none of them have got to have they'll usually have a pretty precise full scale voltage rating, but the current might vary. I mean, excuse me, the full scale current rating, but the voltage, the terminal voltage might vary a little bit depending on what that coil resistance is. So you always have to trim them. You know, it's just
that's it, because because anything like that, just like a speaker cone, there's distortion that's introduced by deflection.
Yeah, and the meters themselves, the good ones will actually have little balance weights on them.
Oh, wow.
And so if you ever notice, sometimes you take an analog meter, you hold it this way and it's on 0, but if you lay it flat, it's not on 0 anymore.
Right.
That's because the balances aren't set right. And that's a very, very delicate adjustment procedure that experienced meter techs could do that I could never master. But
have you noticed that with your AVO?
Well,
with the old,
on the Simpson 260s,
on
the 260s, some of them aren't quite perfectly balanced. So you want to use them in the position where you calibrated them. Okay, calibrated them flat.
So we were always taught. We were always taught to lay them flat on the bench.
Yeah.
Oh, really?
That's generally how they were calibrated.
And I thought the pivot point wanted to be upright. Yeah, that's interesting.
Yeah, but think about it. The needle's not weighing. Yeah. The needle has no it should be balanced with the coil, and it ought to be balanced exactly on the pivot.
Right.
But when it's upright, if it's over to one side, it's
pulling. Yeah. The weight of the needle itself was pulling on the springs when you're upright, but you're not when you're laying flat.
Got it.
Yeah.
So didn't quasi-peak, didn't that measurement that we use in RF come from trying to emulate what a meter would do?
It did, actually, because it's funny because we're still using it today, but the whole quasi-peak measurement from an RF standpoint came out of how much of an interference in terms of amplitude and duration is sufficient to disturb an audio broadcast signal. Like we'll take out words.
Okay.
So that's where it came from. So the stronger the signal would affect overloading the receiver and the receiver recovering from that. And obviously the duration of the signal would affect how long it would last as well. So basically experimentally they determined, okay, there's this rating factor of amplitude versus duration that would be sufficient to cause distortion or disruption of an analog broadcast transmission. And the way they actually measured it was basically a crystal diode detector to measure power, and then measuring the voltage with something like a Simpson 260. So the inertia of the meter movement actually fed into the spec, because how fast that meter would move and respond was part of the response of the quasi-peak detector.
Yeah.
So even though today a lot of EMI standards still use quasi-peak detect, it has absolutely no bearing on the interference of modern communications, which is bursty, high data rate stuff. There you go.
This is for you, Frank Buss.
Love that. Love that.
But Frank, at some point, I'm going to check out your meter simulation because I like those too.
That meter looks very, very much like I just picked up this year.
These are all over AliExpress. These are really cheap. And,
that's probably where it came from. But
they're used in a lot of audio amp kits now.
Yeah,
because they look cool.
They got a backlight in them too.
Yeah, it's a warm white LED.
Yep.
Backlight in it.
So I think that's the same meter this guy used, because I picked up this year a low power, we call it a QRP ham radio transceiver that has one of those meters on the front face to measure signal strength. But he did his own scale to make it a meter scale. But it's exactly the same size and form factor as that, so that's probably where it came from.
I think there's just one factory churning out just these in the hundreds of thousands.
Probably, probably in Shenzhen. Yeah.
So those are the Simpson 260s. Oh, back here, this is actually a shortwave receiver. So if I want to listen to something,
of course,
your addiction to ham.
Yeah. So and then the old function generator. This is a Heathkit FM deviation meter, but this one you actually have to adjust the carrier to measure it. And then just an old it's just an old RF SIGGEN up there. The old kind of scale type,
Nice.
So, but that's and then over here, can you see it? You see the end of it over here. That's actually the very first scope that I bought. Was that guy? It's a Tektronix 465B dual trace 100 megahertz or two channel 100 megahertz.
That one's on its own trolley.
That's on its own trolley there too. Yeah. So
very cool.
But then I bought a couple of these Nano VNAs. This is the Nano VNA H4, and this one here is the Nano VNA V2 Plus 4. I bought them mainly because since I got the YouTube channel, I do videos on them, and I can write off the cost of these things against the money I make.
You are the standard, the person I've heard when somebody talks about how to use a micro VNA, they say go check out W2AEW.
Yeah, I got a bunch of videos on that. So
now talking about ham though, one thing I'd love to get a tour of while you're at it is your mobile kit.
Okay.
Because I don't think I've seen anything quite so compact and powerful. I've got a friend, Chris. Chris, I hope you get to watch this. Chris Carlson, I used to work with him. Yeah. He's building his into a backpack, but it's going to be big and heavy. And but yours is like truly compact.
So this is really compact. So one of the things that I got into this summer is an amateur radio program called Parks on the Air, and it started in 2007 or 2006. The ARRL ran a program called National Parks on the Air. It was to celebrate one of the significant anniversaries of the National Park System. And after that, people said, that was fun. Let's just do a Parks on the Air thing. So it doesn't have to just be national parks. It can be state parks too. So I kind of got into, you go up, set up in a park and, make some contacts, quote unquote, activate the park. So I kind of got into that this summer, and it kind of bit me really hard. So this is one of the things that I got to do that. So, so this is actually, most of what's in this actually comes from a company called Elecraft. They make some really great radios. So inside this kit, I've enhanced it a bit. What's in there? So I'll just open this up and start pulling things out. But actually, you can kind of see there's a bunch of stuff in here. You
did stretch. You did stretch the pouches on the bag.
I did stretch the pouches. So what's in here? So the main thing that's in here is the rig. This is an Elecraft KX2.
Oh, that's a sweet little radio.
Yeah. How big would that have been 20 or 30 years ago?
Oh, well, yeah, this 5 times the size, 10 times the size.
Okay, yeah, that's what I was thinking.
So this doesn't cover all the HF amateur radio bands. It covers from the 80 meter band, which is 3.5 megahertz, up through 6 meters, or might just do 10. I don't know if it does 6. It does 10 meters, but covers basically the HF bands, which is what I wanted. I use it primarily for CW, for Morse code, but really great. It's got a self-contained battery in it, so the battery will run this radio for, even with transmitting the way I would use it, could run it for hours. It's also got a built-in automatic antenna tuner, so I can hook up this random wire antenna and be off running. So great little radio.
That is fantastic. So that's cool. Like that really plays into the mobility too, because you could just get a piece of figure 8 and throw it up over a tree branch.
Exactly right. So, and I've got a couple of different options for antennas. So one of the things that Elecraft sells is this little antenna, which is just a loaded coil and a telescoping whip. They call this.
I like how they made it in a clear case. That's really sweet.
And this one is good for like 10, 17, and 15 meter bands. And I could set this up in minutes, beyond the air. So which is really cool. So just some 25 feet of RG174 coax feed line. Also in here this is a little mini Morse code paddle to do Morse code with.
That's cute.
And then this is about a 15-foot counterpoise ground wire to connect to the radio and throw out on the ground.
Right.
Okay. Oh, really cool little mini CW key. I want to do straight keying operation. So
that is so cool.
So let's see what else I got in here. So there's a microphone in here, tiny little microphone. This guy, that antenna, I actually made this little window mount, so I could be in the car, slip this over the window of the car, put the antenna on there, hook the feed line on there, and literally in 2 minutes I could be up on the air. So sometimes when I'm traveling, I'll give up lunch and go set up at a park somewhere, set this thing up, and be on the air in like 5 minutes.
That's how you do it.
Yeah. So I got a little logbook to keep my contacts in. And then in here also, I won't take it all out, just to kind of show you. There's actually a 40-meter end-fed wire antenna on this loom thing right here. There's a couple of other little coils of hanks of wire that I can use as random wire antennas. I've got a couple of other hanks of wire here, a couple of pencils.
It looks like a toroidal balun, or is that part of the orange one there?
Well, it's actually part of that was actually part of the orange one there, but I actually have it's buried in here. Here it is. Here's another one. This is a 49-to-1 transformer. So I can hook up an end-fed half-wave wire to this, BNC connect this up to the thing, and that basically becomes the feed point for an end-fed half-wave wire antenna. So
nice.
So, but this whole, now of course, this doesn't give you ways of suspending and holding the antenna up. I've got a couple of pieces of rope in here. I've got a weight that I can throw over a tree branch.
Right.
But I also, like if I'm traveling in my truck, I'll usually have a couple of telescoping poles or even a throw line to throw, like an arborist throw line to throw a wire, a rope up into a tree to pull an antenna up. But the minimalist kit is just this whole thing, just kind of zip together and boom,
It just gave me an idea too. What if you could have a really nice, strong, spring-loaded clamp, much like what we use in woodworking, that has metal contacts on the inside, and your feed point on the top. You clamp that onto either the fence railing or play structures in parks.
I've done that.
You have swings, and you can use that. That has really good grounding. So I've played with a bunch of different antenna configurations. I've done things like that. I've clamped to fence posts. I've taken a telescoping rod and just bungee corded it to a parking structure, type of thing. But it's just fun to set up something simple like that beyond the air. And as that radio will put out a maximum of 10 watts, I typically use it at 5. And make contacts all over the place. You mentioned when you travel, do you still travel quite a lot for your job as an FAE?
Yeah, so I'm on the road. I'm not. It's coming back. COVID really shut all that down, but it is coming back. So I'm still traveling, and so like I said, if I'm traveling for work and lunchtime comes up, and I happen to be near a park, I'll go set up instead of taking my lunch. I'll go set up and play radio for an hour instead of getting lunch, and then go to my my appointment or something like that. Yeah. So.
It's a good way to squeeze it in, because we all have busy lives and we have families. And I was thinking, both of you guys have very understanding spouses to have. Oh yeah.
Whoops. I didn't mean for that to jump up there, but this was my early radio experience. I was in the National Guard, and so whatever frequencies those are, I can't remember, but
they're probably all HF. Yeah.
Yeah, we'd show up and put up our 3/8 ground plane antenna and ground wave antenna and stuff, and
little RTTY transmitters and stuff.
Yep.
Nice, very cool. So,
whoops. Yeah, let me get rid of this. There we go.
The parks on the air stuff. A lot of people will use various digital modes to communicate. Like there's a very popular one now called FT8. To communicate where it's almost kind of an automated thing. You don't really interact with it much. I like using CW. It's just kind of very tactile and, kind of primitive in a sense. And it really does a nice job, especially when you're dealing with very low power, because, you get a 20 dB advantage with the narrow bandwidth for CW compared to something like a single sideband or something. So
how has ham changed in the last 20 years? Has it gone down, gone up, or technology has replaced half of it, or what's changed?
Well, what's changed a lot is the reason people get into it. Right. Yeah. It used to be, 30, 40 years ago, people got into ham radio because there's a way to communicate where you couldn't communicate at all. Now you can communicate with cell phones, internet, things like that. So people who get into it are more interested in the technology or just the magic of it being RF, you know.
Right.
So that's a little bit of a change. There's been a lot of advancements in terms of, you know, introduction of using computers along with M radio for doing various digital modes, from simple phase shift key things like PSK31 to more complex low power communications like FT8 and FT4 and things like that. So
and you can see you can see that on YouTube. The people with the ham focused channels are doing all of that sort of stuff, or doing really interesting things with satellite communications. And CubeSats are a new thing. They didn't exist years ago, but they do now. And if you have a ham license, it just makes like for schools, universities, and even high schools, there's what I've noticed in QST magazine is a mix of like the previous generation and the brand new generation, like high school kids. Right. And there's like two extremes. It's a bathtub curve.
I think there really is. Yeah, I think there really is. There's I'm 60. Oh, when did that happen? But I became a ham when I was in high school, back in the late 70s. Kind of dropped out of it for a little while, but then kind of got back into it. But you're right. There's a lot of graybeards, and there's a lot of young people getting involved. So.
Yeah, all the Hackaday writers, they all went out and got their ham in mass. It was just like a tech thing to do.
I think if Jerry Ellisworth does it,
they're right.
It's an encouragement to anyone else in our kind of circles to go do it. Yeah. I did it in 2020. I got my first license, and like you said it exactly, Alan. My reason for doing it was like, I'm a computer systems engineer. I love FPGAs and coding, and I love PCB design and electronics hardware. I've been into electronics since I was 8, and I'm mostly interested in audio and signal processing. And I'm like, but somebody needs to help other PCB designers understand RF. And that earlier that year, I put together a course for PCB West on all the basics you need to know to really understand what's going on in RF and microwave board layout.
Right.
And I'm like, I might as well get my ham license. Like, I might as well just jump in both feet and force myself to go, essentially take myself back to school and go through all of that.
Right.
And it was great. It's a great experience. I encourage anyone to do it, even if it's not your normal thing.
There's so many different aspects to it that it's not just sitting there with a radio or a key or something like that. There's so many different aspects to amateur radio. So,
and what's more, it's
Scriber.
It's a communication backup that I think is you can't really put a high enough value on being able to communicate if there's a national, if there's some sort of disaster or emergency. The phones aren't going to work. I'm sorry. Like if all the power's gone out, like what's left? Radio.
Right. I was in the National Guard during the blizzard of 78, which if you're from the Midwest, everybody knows about 77, 78. And the bottom of the armory was full of hams. When the blizzard hit, 5 foot of snow, all the hams just knew to come to us. And that was our fabric for talking to all our different trucks and stuff that didn't have the military radios.
Yeah, I saw the comment about Scriber, but I'm surprised that you don't see too much of that, because I don't know if you're familiar with that. Scriber is a kind of a spread spectrum communications, if you will. What you do is you send out signals at different frequencies, and if you plot the spectrums in a waterfall display, like basically a strip chart record, if you will, of spectrums, it actually draws pictures. You can actually form letters and things like that. So literally just visually you can read things, because it created the tones to spell out things on a waterfall display. So
it's like a player piano.
Well, I was going to say
it's like a player piano.
It's like draw the sky, the planes that use the smoke dots to
exactly right.
Yeah.
Hey, I know we started off wanting to talk about the curve tracer. We haven't talked about that at all.
We haven't.
So I can certainly switch to cameras and show that real quick.
Okay.
Oh yes,
let's do that.
Yes.
So I know it's just one of those things that we kind of get off on.
And we don't have a hard fast stop time, so we can talk as long as you can.
Okay, well, I'm good. So
well, I shouldn't speak for Ben, but I can.
Yeah.
Yeah, I can't talk all day. I do.
Well, see, it's the end of my day, so yeah, it's the end of my week.
All right. So yeah, so this is the Tech 576 curve tracer.
That thing is huge.
It's a pretty good size unit. So it's twice as deep as it is wide. It's a big unit.
I hear a coming off of it though, kind of like an aura.
Like, so Mike had his 577 up. With the 577 is about that wide. Okay, so there's just a couple of additional features that the 576 brings over the 577. But and there's a bunch of little like fixtures that were available to plug in, to plug in here, to plug in for transistors and diodes and things. But I oftentimes just make little adapters. So I've got a diode over here. You can actually just see, I can just adjust and measure the curve of that diode. We can switch it over to AC mode, so we can actually measure if it was a Zener, I can see the breakdown of the Zener, type of thing. But
what kind of voltage do you get up to on that one?
This one can go up to 1500.
So it could do tubes theoretically.
It could do tubes. You'd have to build some fixtures for it and provide your own heater supply and things like that. But you could sweep tubes with it. There was the 575 that was more geared towards tubes. In fact, it was actually vacuum tube based. This is solid state. Interesting little thing here, if you can kind of see here, this display, these numeric displays here, you can see how they change if I change some of these things.
Oh, wow.
This is actually a incandescent fiber optic numeric display. There's a bunch of fibers that are running back from here to a whole set of incandescent bulbs that get turned on and off depending on where you set scales, and those bulbs then light through the fibers to create the letters. It's incredible.
Oh goodness, that's amazing. I had a display like that which I threw out, and I wish I'd kept it. That was not fiber optic, but it was projected, and it was a single 0 through 9 digit display that apparently was designed to go in a helicopter dashboard.
Oh, really? Okay.
But it had 9 light bulbs with little what do you call them? Where it projects light through pipe. Little apertures for the different numbers.
Yeah.
Okay. And it would project them onto an opaque screen.
Yeah.
Oh, look at that. That's cool.
So that's Kurt. There's a little 2N2222. Actually, interesting little fixture here. This wire harness came out of an old VCR, and I picked one that had just 3 terminals, that plugged into a board somewhere, and I stripped out the other end and put banana plugs on them, so it makes like a little transistor.
Perfect.
So
why not?
Because rather than use one of these little fixtures like this. But really cool. I mean, there's so many things you could adjust here. You can zoom in on certain areas by playing with display offset and scaling. You could change the number of steps that we're actually doing. You can offset those steps. You can have the steps be either positive or negative, so you can look at JFETs or enhancement mode FETs or bipolar transistors.
That is great.
But it's kind of cool. A lot of just multi functions on the knobs, like this knob here, which adjusts the peak voltage that you're going to sweep over. Also, you pull it and it adjusts the series resistor that's in series as you turn the voltage up or down. So, and which one of those has a different, so depending on where if I sweep this up here, I could change the resistor that's being used, and you can kind of see how that's affecting, the amount of current that I'm getting.
Yeah.
Okay. So.
And these things, obviously, these are a thing of the past as well, but camera hoods.
Yeah.
How hard I guess you'd probably have to make one now, but do you see camera hoods for analog scopes and curve tracers still available anywhere?
You still find them. People will make them or home brew them nowadays too.
I guess it's a perfect project for a 3D printer, really.
Yeah, it really is. Yeah, especially now you can make them so you can put your phone or some other camera in front of it.
Yeah, we used old Polaroids back in the day. Yeah.
Yeah. I've got an old vinyl one that I can use.
So I have a question about this too. I have a question about this. So
yeah,
I'm thinking, because the reason I was thinking about camera hoods, all right? So electronic device manufacturers needed curve tracers so they could characterize the devices and then create a data sheet, and they would
yep,
give you the curves in the data sheet so you could design with the device.
right, yep,
But you had to trust that the data sheet had the nominal of, so they would do a batch of 1 million JFETs.
Yeah.
right.
And you're like, well, I want to know that I can use 100,000 of these, and they're all going to be pretty much the same. So how would they go about that, averaging, or making sure they all fit?
Well, I think back like in the era of like something like this where nothing was automated, typically things across a lot or in a given area of a wafer would be pretty consistent. So they would do some sampling of different quadrants in a
Right.
lot and say, okay, that's what this one
Different
is.
parts of
Right.
the wafer.
Right.
Yep.
Exactly. Later on, there were programmable versions of these where it actually could pull data and things like that. And then also at the manufacturing side of things, there were test coupons that were typically as part of the wafer manufacturing that could be used to characterize things like doping levels and things like that, so that
Right.
you would,
Okay.
better know the fab status, of the product, so they would come out more consistently. But that's
So
typically done more even at the wafer level than it is at the individual device level.
I
that makes
remember,
perfect sense. Like we do coupons on board fabs
Exactly, same thing.
as well. It's the same thing,
Yeah.
and we measure a few coupons from the edge and from the center of a panel
Right.
to make sure their impedance is like their lamination cycle is good enough to maintain within spec.
Right,
Same deal. Yeah.
I remember back an HP engineer talking to me about green LEDs back when green LEDs were hard to make because the frequency went from yellow green to blue green all over the wafer itself.
Yeah.
So it was hard to get 7 LEDs to match to put in a 7-segment display.
Oh.
And their way to make the wafer be continuous across it was to go to gaseous phase epitaxial deposition.
Okay.
Instead of liquid, and it's like, they used high pressure gas with ions in it to make the wafer be representative across it.
Yeah. So, but yeah, so this actually, this actually, like I said, this actually came from a friend of mine at Ham who's since passed away. But in fact, the other one I have over here is from his son. He wants me to kind of refurbish it for him, so it's sitting over on a bench. But that's where this kind of came from. So I always very thankful. I always think about him when I'm using it. But yes, that's the bulk of what I have here. I've got a bunch of other projects sitting on the ground, but this is I'll use this quite a bit. In fact, I'm putting together notes for my next video, which is just going to be a kind of a back to basics on a bipolar transistor. So I'll be using this as part of that video.
Oh, that's so cool.
Yeah.
That's so cool.
So when you say refurbish, are you going to like replace all caps automatically, or do you go in and refurbish just what's needed? Or
in most cases, especially with this particular instrument, there's only a handful of caps that are probably going to want to replace just due to age. For the most part, the quality of the components that went into these things was unmatched.
Yeah, the best.
So it's going to be cleaning switches, getting switch contacts clean, making sure that nothing is just dead. There's a lot of plug-in connections from like board to board and board to wire harnesses and stuff that need to kind of be cleaned. So it's not like a full restoration. I just want to kind of get it up and running for them and clean it up.
Got it. Yeah, they used real gold on even cheap, mundane interconnects back then. Is my memory.
Yeah, these are incredibly well built. It's like, in fact, the video that I did on the 576, I've got the panels off it so you can see inside it. It's pretty cool.
Yeah, I just Googled it and it came out in 1969, it says.
Yeah, they produced this from 69 until the early 80s.
Wow.
So, yeah. So, but great cool unit. So, but so lucky to have this one. In fact,
yeah, they go for quite a bit on on eBay.
I've got customers that will buy any one they can find on eBay to use as parts to keep the ones they have running. Because the failure analysis labs and things like that love these things. So.
But no automation, no HBIB connector on the back.
No, there was a 377 series that was a bit wider that was all programmable and things like that. Had a little bit of a smaller CRT, but you could pull all the data out programmatically and stuff. But this was kind of the last of the big boy
Right.
big boy units. So.
Big boy pants. Yeah.
Yep. So fun
very
stuff.
Cool.
That's amazing. Wait.
Yeah.
So
10 minutes pass. I really quickly also wanted to just give a shout out to my friend Maridel, who has the Altium. He has another Discord channel and has generously built an Altium library online for everyone to share for free called the Celestial Library. So if any of you are using that, and he is a super generous friend of mine, sent me this. So I have actually a really good lab power supply now. Thank you so much.
Very nice.
He's also known on the Discords as Isis. But what a great guy.
Nice.
He was
nice.
Very cool. Very cool. So I've got a question for you regarding Tektronix. Do you have any of the TM5000 chassis, or do you remember the 500s and 5000s?
I do. I used to have a TM504 chassis that was fully. I think I had the DMM, the function generator, a power supply, and something else. But I remember, probably 10 years ago, I traded it to somebody for something else, so I don't have it anymore. And then the TM5000 was the GPIB programmable version of the TM500.
Yeah.
So, but I don't have any of those modules or chassis here anymore. So.
I've got a power supply in a 5000 chassis, so I've got like a precision one, and then something so I can dial in 1.2, 1.8, and 3.3 volts was the intention.
Okay.
It's just the currents that they used back then. The supply's only good for like 150 milliamps on the precision. I can't power anything with that anymore.
I see the question for a modern equivalent. So actually, there's a Japanese company called Iwatsu still makes kind of curve tracers kind of like this, but they're the only ones that actually make a manual curve tracer.
A dedicated curve tracer.
Keithley, part of Tektronix, Keithley has semiconductor parameter analyzers and things like that can do curve tracing and a bunch of other things, but they're not kind of manual twist the knob type of a thing. They're more for characterization, like you were talking about earlier, Ben. But you can curve trace, multi-terminal devices and things like that with these things, very highly configurable. So that's probably the most modern equivalent in terms of the class of instrument that this is in, is like a Keithley 4200 system, which is a semiconductor characterization thing. Unless you go with some of these, like something like that.
This is why it's got built-in function generators, built-in scope capability, so they can create the sweep signals and then read them back at the same time.
Yep.
This is a digital and
if you need high voltages, go for a microtracer 3 or a microtracer 6, which I've got my microtracer 6 kit. I'm still building it, but as soon as it's together, we'll do an episode and I'll walk everyone through that. But that one is more specifically targeted to tubes. I believe I'm going to talk to Ron, the person who designed it, and see. He's agreed to join us on the show too, by the way. So we'll look forward to that when I get it together. So we'll have the person who actually developed it walking us through it as well. It's going to be awesome. But I'm going to be asking him, okay, if I want to adapt this to devices beyond triads and pentodes, I believe it would also be really good for MOSFETs, really any device, as long as his microcontroller software can adjust whatever is needed inside. So
you're talking about tubes. There's my there you go.
We were just right. It looks like his.
This one's quite funky. It needs some TLC.
This is the old Sencor Mighty Might TC162. So
even basic valve go no-go testers are quite expensive on eBay because there's a lot of people wanting to play around with guitar amp valves and hi-fi audio amp design with different tubes.
Right.
So
our drugstore had a tube tester right as you walk in the door, and people would come in with, and that's how they fixed their TV, was take all the tubes out of the TV, go to the store and
I've done that. Been there, done that.
That sounds so laborious.
It's made to be repairable, almost repairable. The most common failed components were user changeable if they didn't kill themselves with the high voltage.
Right.
So when Ben said he's going to be powering up his curve tracer, I'm picturing, Ben, you should get a automatic defibrillator, in case they find you laying on the floor.
That's going to be one of the things that's the hardest part about it is finding a good 20-volt power supply that can deliver a kilowatt.
A kilowatt.
Because the microtracer 6 will step up to 1,000 volts. I don't think it'll deliver 1,000 volts, an amp at 1,000 volts. So I think it's somewhat, but the maximum plate current it will deliver is an amp. But there's going to be some crossover there.
Right.
So how much is a kilowatt coming out of your wall? That's 10 amps, right?
Hey, or eight and a half or so.
10 amps at 100 some volts. Yeah.
That's the other thing I don't like about American power. 117 AC is just not enough.
Yeah.
Everywhere else in the world, I can get 25. I can get 2,500 watts on a standard circuit in Australia because it's 250
my table saw that's sitting out over there many years ago, I wired it for 220 instead of 110 because the voltage drop penalty drops by a factor of 4. So
4.
Yeah.
I did the same with my welder. Yeah.
Mm-hmm.
So very cool. Anything else that springs to mind there?
No, I guess I got a lot of cool just RF stuff laying around here. Here's a nice low power RF dummy load. When you're testing RF transmitters and things like that, you often need to have a 50 ohm resistor to load those things in.
Right.
Here's a nice lightweight 50 watt resistor for you.
But is that like a kilowatt?
This one's good for this one's actually
20.
It's actually rated for 600 watts continuous.
Yeah, and up to what frequency range?
I've actually swept this thing out to 2 gigahertz, and it's pretty flat out to 2 gig.
Wow, that's impressive.
What is the resistor in that? Just a big chunk of silicon? What?
It's actually I think it's a coil, but it's in an oil bath and the whole thing.
Oh, okay, like the.
Yeah, I've seen one similar, a 2 kilowatt 50 ohm dummy load for RF that another ex-co-worker from Altium had. Like the sales managers was also a ham, and his was it looked like an
radiator.
oil radiators.
Exactly
looked like one of them. Yeah.
Oh,
cool.
But
I've not done anything high power enough with my ham setup to warrant a dummy load for testing.
No, I just use that if I'm working on like a 100 watt transmitter or 100 watt transceiver. A lot of them are 100 watts. At least I can load it as long as I want and that all day long. So
and probably hardly even feel like
and I've got a 250 watt VHF amplifier sitting on the floor over there that I need to work on that belongs to one of my club's repeaters that I need to work on. So I've got a nice 50 amp supply here, and then that and the dummy load, I should be good to go with that. So
yeah, it sounds like you've got a lot of work already assigned, a lot of time assigned.
I've got a lot of projects sitting down here. I've got a pair of old HP RF SIGGENs over here. One works and one doesn't, but they're identical, so I can use one to kind of help fix the other one. So that's sitting over there. So it's like I said, I'm just in the basement shop here, so I've got right around the corner is the boiler. You'll hear that fire up sometimes. And
mine just fired up. Yeah.
Sometimes on my videos, you'll hear the electronic damper go tick 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 tick, and then you hear the boiler come on.
Mine used to do static. You'd hear. You'd hear static in the speakers, Bluetooth.
I wish we had basements in California.
Yeah.
It's the one thing.
Oh, they're great, man. You should.
I need a basement, but nobody has. There's like one house in the whole state that has it.
Well, that was the criteria for this house. Is oftentimes you find a basement, but the ceilings are very low.
Yeah.
And I'm 6'1".
Oh.
And so this basement, I can stand on the floor, reach my hand up, and I can't touch the rafters.
Oh, so
I got about 9 feet of clearance from my basement floor to the rafters for the first floor here. So
I have to stand on tiptoe to touch my rafter.
Yeah, I can't. If I tiptoe, I can hit the bottom. I can just touch the bottom of the rafter. So maybe a little over 8 feet then.
it's nice. I've got big light boxes because again, I'm old cold fluorescent, so there's room for light boxes in here.
Yeah, I really should do something to improve the lighting in here. I got just a couple of fluorescent fixtures above here, and I did the under cabinet lighting with that LED strip. But if I shut that off,
so I put under cabinet lighting. I did like the programmable colors. I was going to, do cool setups here.
Yeah.
And the tape just lets go. You don't come down for a month.
Yeah.
You come down and the lights are laying all over the counter.
Oh,
yeah.
This one is held up. I'm not sure. I've had this in here for about a year and a half. It's held up. So and I just bought like a reel of this stuff,
Well, some of the ones. So I had got these other ones off Amazon that were made to replace fluorescent tubes for garage lighting.
Oh, okay.
And they weren't on a tape with a sticky backing. They were on really thin, rigid board that was slotted into a slot in the extrusion, so they'll never fall out.
Yeah.
Right.
But I've had the same problem in my kitchen. I did under cabinet lighting with RGB tapes.
Yeah.
And I ended up putting dabs of silicone here and there just to force it to stay up.
Okay.
Yeah.
Okay. Yeah, this is just a tape, and I actually took some scrap circuit board to kind of make a little baffle so it wasn't shining in my eyes. So.
Oh yeah,
right.
That's cool.
Yeah. I have aluminum foil on over the bench, fluorescent, same thing. Yeah, keep it out of the camera.
So
but yeah,
so it's all fun stuff.
Yeah, well, I want to thank him for joining us today.
Yes.
It's been a lot of fun here, just going from right to left, just what we can see in the camera. And there's so much more that we can't see.
There's actually a lot of little things like old little LCR meter. This one I use this one a ton, and then I recently picked up. Well, I guess a couple years ago, picked up this guy, this DERE.
Yes,
you see these around a lot. There's yours right there, right?
Hey, and guess what, Bill? I did get the little infrared serial adapter.
Oh, nice.
Oh,
nice.
did you?
And I'm glad I did. I'll tell you why. Let me share my other screen.
Yeah. What's it useful for?
It came with this software. Let me see. Share screen. That one.
Yeah, because I didn't know what software I would use with it, or terminal or anything.
It came with this.
Oh, neat.
So, and I hit the little PC button on the thing, and I've just got a little MLCC cap on it right now. But look at this. I can press the play button or record and run, and it just records data. I need one thing that is a little bit off on the UI is pretty good in here, but this graphic display, you have to set the range. You have to set the range. So I'm going to change that to. Is this on PC mode? It is. So I'm going to set the range. Like I say, every second it's updating here. So I can change that. So basically I can do data logging with inductances and capacitance. So it's showing me it's 96.6 nanofarad and it's updating over time. I don't know why I can't change this drop down here to change the graphic. I've only just loaded this software for the first time just before we went live. So haven't looked at all the preferences or anything yet, but yeah, I mean, so I can save all of that and I can export that. I'm sure I could stop and save it out as a CSV file or whatever too. So that's going to be useful when I'm hand winding inductors for and transformers for audio frequency crossovers, for boost converters, because I want to do some boost converter designs for generating high voltages for driving vacuum tube preamps,
right?
Stuff like that. It's just going to be super useful.
I looked at coil winding machines, hand winders, back when I thought I wanted to make listens, as a source of income, LISNs.
Oh yeah.
Yeah. And thank goodness I came to my senses. But I was researching the coil winders and everything for making your own,
Yeah. I want a lot of small toroids and things like that for.
Now those are that's where you want a machine that can do it. But they're very
well. Yeah, the
tricky
problem was,
machines.
I don't have the machine, so the trick that I wound up using is I took a chopstick and whittled it down to make it a little bit of a sharper point, stuck it in a bench vise, and I stuck the little toroid over the chopstick, and then I could use that to kind of hold it as I was kind of
lacing it,
lacing it around. I put a little slot in it so that one spotter could slide the wire up, and without taking it off, I slide it up, rotate it around, slide it up, and that really made it easier to wind a lot of these.
That's a neat trick.
Where's my chopstick?
I had to hand wind inductors for DC converters when I was 18 and I just graduated high school. My first job in my first year of college, I worked 1 day a week at a medical power supply company in my hometown, Hornsby, New South Wales. And sometimes they didn't have enough of the factory stock of some inductors, so we would have to wind them because a big order would come in and they'd want the money. So they'd say, okay, you guys are knitting. Let's say you guys are knitting today. And we'd, no, not that again.
Yeah, because I had picked up a couple of these little kind of like little clamshell things to hold the toroid. But the problem is it was made at they'd break. Like I broke the ends off of that one, I broke the ends off of that one. So here's like for a T30 or T37. Here's one for a T25. So
very cool. They are really small.
Yeah.
Toroids.
Yeah, these guys are really tiny. These are little T25s. These guys here are these are T50s. So
could you imagine being a factory worker back when they were doing magnetic core memory?
Oh my God, no! Yeah,
I remember seeing anything more painful.
Oh my gosh, I remember. Well, I saw Jerry's video on those too, but I remember just seeing those boards of those core memories all laced together.
The ropes that were used in the AGC of the Apollo stuff, they were big ropes. They would fold into the ROM. Were big ropes but a woman sat there and stitched it based on the program from the programmer. It took them 6 months to make a rope, something like that.
Crazy.
So excellent. Well, thank you again for coming by.
Yes,
this was fun. Yeah, it was good to see you too. So,
yeah, thanks,
the picture that you put up was, I guess, from 2015, so like 7.5 years ago.
It was a while ago.
I had a lot more hair back then, apparently.
Yeah.
I didn't. I shaved my head when I was 21 and never looked back.
Okay. Yeah, I think I started doing this about 3 or 4 years ago. It's just a lot easier. I could just do it myself. So.
Yeah, I don't want to talk about how long my hair was when I was 21.
I've seen pictures.
The rest of your life going.
As my hair got longer at the back, it got shorter on the top.
Yeah.
Right.
Well, that problem is that I lose it up here. Yeah.
You got back to here, and I'm like, no, this is not a good look. I'm just shaving my head.
Now, my problem is that the more I lost here, the more it would come out in other places, like my ears. And
it's like it's a cruel joke.
Exactly.
Yeah. So,
same amount of hair, it's just in new locations. So
yeah.
All right. Anyway, this was a lot of fun. Thank you very much.
Yeah, thank you again, and we will see everybody, if not next week, the week after.
And everyone, if you haven't, I'm sure almost all of you already have subscribed, but please go subscribe to Alan's channel, W2AEW on YouTube.
Right.
It's definitely worth it.
He's got his silver platter.
He does it just out of the love for the craft and helping people. Obviously, you're a very generous soul, Alan, and your channel is a testament to that. So thank you again.
Thank you.
So, excellent. All right. We'll see everybody around. And until then, everybody have a safe day, a safe weekend.
It's 7-3.
See ya.
All right.